Welcome back, everyone. We're going to be solving LeetCode 246, Strobogrammatic number. So we're given a string called num, which represents an integer, and we want to return true if that number is a strobogrammatic number. And they define a strobogrammatic number as a number that looks the same when rotated 180 degrees. So 69 will look the same, 88 will look the same, and 962 will look the same. So essentially all we have to do is, we're working with a string, so we cannot modify it. So we're going to have some sort of array, right? And let's extend this array to be the same length as our number. Right, we're just going to return a string join at the end. Let's also have a mapping, and that will contain the numbers that can be rotated. So 6 can be rotated and it will look like 9, and 9 can be rotated and it will look like 6. So now what? Now let's make a set to contain the numbers that we do not want. And so it'll be character, for character in range. Can't do that. I could. Actually, we'll just make a tuple. So the characters that cannot be flipped, right? So 2. 2 doesn't look the same as 2 flipped. So we've got 2, 3, 4, 5, 7. I believe that's it. Okay, so now what can we do? Essentially what we want to do is loop through our number, grab the character, and place it in our array, right? But we know we're going to have to, if we do that, right, we'll have 6 will become 9, so we place 9 inside of our array. 9 will become 6, we place 6 inside of our array. So inside of our array, it's going to be 96. So what we have to do is reverse that at the end, right, when we return our string join in order to get 69, which is what we're looking for. So instead of having to, loop through, do an O of n runtime to grab these numbers, put them in our array, and then have to do another O of n operation in order to reverse the array to get what we're looking for, we can just use a pointer. And we will set this pointer to be equal to the last position in our array, right? So if our array is of length 5, we have 5 elements in it, so we will set our pointer to be 4 so we can get the very last element inside of our array. Okay, so now we can loop through our string. So we'll say for character in num, if that character is in the tuple SSS, right, we know that those numbers cannot be flipped, so we can just return false automatically. Otherwise, if that character is in our mapping, what do we want to do? We want to place that number inside of our array, but the flipped version. So we will say array at position, right? We're going backwards instead of having to reverse it at the end. We'll just do it all at once. So we need the pointer, at the pointer position, that will now equal mapping of that character, right? So if it's 6, it'll be 9 in the whatever position we're at, right? And then once we do that, we have to update our pointer, so we'll decrease it by 1. Okay, so what if that character is not inside of our mapping, right? That means we can just append the, we'll just place that character inside of our array. So we'll say array of pointer will equal character. And then we'll update our pointer. And then we can just, let's print this out so you can see it first. Print out a, what? Print out array. We'll print that out. So what do we get? So we've got 6, 9 in our array. So once we do a string join and return, we'll get the correct answers here. But I guess what I'm trying to show you is that by reversing it, by using a pointer, we can just add the characters in reverse order instead of having to, you know, reverse our array at the end. So now we can just return this, return the string join of our array, get rid of some spaces here. We'll run this, pass all the test cases, submit. So what did we do wrong here? Okay, so we actually have to compare to the number. Submit, and there we go, it runs. Okay, so what are the time and space complexities of this? Well, the time complexities are going to be, we have a for loop here, so this is going to be O of n. Right, we're using the in operator, which is generally O of n, but we're using it with a map, so this is O of 1. So this entire thing is going to be an O of n runtime, so we'll say O of n. And then our space complexity is going to be, the pointer is just constant. Space complexity is going to be the length of our array plus the length of our mapping, plus the length of our tuple that we created. So the space complexity, again, just down here, just to type it out, it'll be the length of our array plus the length of our mapping plus the length of our tuple. Okay, that'll do it for LeetCode 246.